Sulforaphane's a funny word, but it is a tiny little molecule which comes from the broccoli family. And in this particular case, it is far more concentrated in a little broccoli sprout that's been growing for about 3 or 4 days than it is from the vegetable. Most of the precursor compounds that make the sulforaphane are concentrated in the seed, and then as the seed grows into the mature vegetable, basically the bioactive compounds get diluted. So therefore, the seed is what we use to produce sulforaphane in greatest quantities. Interestingly, we used to think that cruciferous vegetables, that's the broccoli and the cabbage and the cauliflower and all of that family, we used to think that they were rich sources of vitamins and minerals, and we thought that that's why they were good for us. But as it turns out, there are lots of other little chemicals in these plants which have even more profound effects. So sulforaphane is one of those bioactive compounds which has quite profound benefits on human health. So what sulforaphane does, when it gets into your cells, it activates a little molecule called NRF2, which we can consider to be something like a switch, and that then switches on hundreds and hundreds of protective genes in our cells. So the way Mother Nature has organised these genes, the ones which have most protection on human cells are grouped at the other end of this NRF2 switch. So if you use sulforaphane to activate that switch, you're switching on hundreds of protective genes at the same time. So then to consider what is sulforaphane good for, we would have to say that what it's really doing is it's improving the function of every cell in the body. A number of clinical trials have already been done on sulforaphane, and these are across a range of different conditions. One of the earliest ones was done on metabolic syndrome, which looks at the forerunners to type 2 diabetes and to cardiovascular disease. And then there have been some subsequently done on a specific dose of sulforaphane in type 2 diabetes with beneficial effects. So when we look at the research that's been done already on sulforaphane, there are a number of clinical trials which have taken humans and looked at particular conditions and given certain doses of sulforaphane. So amongst the studies which have the most significant effects in benefiting human health are studies looking at type 2 diabetes, at asthma, at emphysema, even autism, which might seem like an unusual one, but because sulforaphane has a very potent anti-inflammatory effect, it tends to benefit conditions which are associated with inflammation. And autism has more recently been shown to be associated with inflammation within the brain and also oxidative stress, which is also related to inflammation. So in addition to those studies, there are also other ones which look at prostate health, also others which look at minimising the adverse effects of environmental pollution. So there's a whole host of different conditions which are being studied now in relation to sulforaphane's benefits. Sulforaphane activates the switch in the cell called NRF2, and that switch is what switches on hundreds and hundreds of protective genes. Now, as we get older, the activity of NRF2 tends to decline, and also if we're unwell. So giving NRF2 a boost with a phytochemical like sulforaphane gives us that little edge, and as we get older, we certainly can do with that advantage. So whether or not one has a particular illness, one can take advantage of this activation of NRF2, and so sulforaphane is an easy way of doing that because it's such a potent activator of that NRF2 switch.